Okay, good morning to all. I'm Mr. Khan. Welcome you in Mr. Khan Academy. Today we are going to cover the part 10.2 of this 10-part series of Introduction to Arduino Programming. And in this video lecture, we are going to cover serial time clock and also we are going to discuss regarding the wire library. This is the last part of Introduction to Arduino Programming. Already I cover various program based on Arduino programming. You can check here some previous series, Introduction to Mechatronics. Introduction of Arduino programming is series is there, what exactly the 10 parts, what kind of program I covered, and the last two part 9.2 stepper motor and part 10.1 how to control the servo motor with the help of computer. The various video based on Arduino or mechatronics which is available on my channel. The links of various videos are available in my description box or this in card icon, or you can visit my channel www.youtube.com/mrkhanacademy. Before starting this video lecture, I request my viewer at the end of this video, if you like my video, please hit the like button. Share this video with your friends also, those who need it, and do not forget to hit the subscribe my channel to motivate me to make a such video in future also. Now already all 10 parts I cover, as I said, 10.1 serial to servo. On this topic I cover, and again in this topic we are going to cover the remaining part of this part 10, that is serial time clock and wire library, as I said. The flow of this video lecture, I am going to first give some introduction regarding the what is RTC, what is I2C communication protocol. After that we'll discuss regarding the component details, circuit diagram, coding and demonstration. Now what is serial time clock? Now Arduino is a fairly precise internal clock, no doubt, but it is not suitable device to keep a track of date and time. Because of that, to get a reasonable accurate date and time with a little backup, we are using here RTC, which is real time clock model. The main function of RTC is to keep the track of date and time even though it is in off state. For example, our computer, our system, even though it is off for several hours, but when we start the system, again we are getting the exact date and time, even though it is does not supplying any kind of power. How it is possible? Because of RTC models. Such type of models is also in computer. Because of that, we are getting the accurate date and time. Now here we are using the RTC DS130. It's a really simple device that uses a I2C, that is an inter-integrated circuit communication protocol, sometimes called as a 2-wire. Because of that said, we are going to discuss regarding the wire library. Why we are discussing library? Because here whatever the RTC model that DS1307 we are using, that works on I2C communication protocol, that is inter-integrated circuit communication protocol. That inter-integrated circuit protocol, you can see this part 2 SCL and SDA, that we'll going to discuss in detail. If any module which is having SCL and SDA, we can say that module works on I2C protocol or 2-wire protocol. What is 2-wire protocol? Why it's calling we are saying the 2-wire. What is I2C? We'll see in detail in next slide. There is a schematic pic of pictures of that module I2C. This is we can say this is the top view, this is the bottom view. We can say here is some kind of battery backup. At least we had the battery having the life of approximate 3 years. That means 3 years, whatever the date and time is set, we are getting the same date and time, variable to retrieve the date and time. Now what is I2C? Now next part. Here RTC already got RTC from that, with the help of that real time clock we are getting the date and time. But that date and time when we are retrieving, that time we are using the I2C protocol, that is inter-integrated protocol. It's an interesting serial protocol that uses 2-wire, that is SD as I said, and SCL, real data and serial clock. Now already some kind of communication we explained in the last part 10.1, which is serial communication with the help of serial monitor and Arduino. But here suppose I connected the Arduino with another sensor or number of mini sensors. If Arduino want to communicate without using serial monitor from Arduino to from that other sensor, that time we can use this I2C protocol or 2-wire protocol. All I2C masters and slave devices are connected with only those 2 wires. What it does exactly mean, we will see in the picture. For example, assume this is Arduino and these are the various sensor or control we can say. Here we can attach up to 112 slaves. Slave is nothing but from which we are retrieving the data, and master is nothing but sending the signal to retrieve the data. From the master we are communicating, and slaves just send the data. He cannot command the master to send the data. It only fulfill the requirement of master. Now the master connected all the slaves, might be sensor, might be actuator, whatever, with the help of these 2 wires. That 2 wires is nothing but SDA and SCL. You can see each and every that slaves, they are having the 2-pin SDA and SCL. Then and then we can see that device works on the I2C protocol. If that pins are available, then and then that device works on I2C protocol. Then the common SCL pins I connected and common SDA pins we are connected. As this is our open, to get the power driven, we are using the positive VCC with connected with some kind of resistance. That I want to explain. All the I2C masters and slave devices are connected with only those two wires. Each device can transmit and receive or both. Some devices master, they generate the bus clock and initiate communication on the bus. Other devices are slaves and respond to that command on that bus. What does it mean? As I said, masters retrieve the data from that particular sensor with the help of some kind of address, that each and every slave is having some specific address. With the help of that address, masters identify that device and that send the command and retrieve the data. But slaves cannot send any kind of command to the master to retrieve the data, because of that master does not have any kind of address, but slaves are having the address. That I am explaining over here. Some devices are master, they generate the bus clock and initiate the communication on the bus, and other devices are slaves and respond to that command on that bus. Now next part we will discuss regarding the pins of Arduino board. How to identify which pin we need to connect for SD and SL in Arduino board. No doubt for I2C protocol, whatever the devices sensors are there, they are having the separate pin which is easily identified, as we saw in previously for that DS1307. They are clearly mentioned that SD and SL pins are there. That device we can easily find out. But from the Uno, if you see the Uno, nothing anywhere printed what is SD and SL. It might be Mega we are getting, but Uno we are not getting. Because of that, here clearly mentioned that Uno in internal sheet pins are A4 and A5. A4 pin is SDA and A5 pin is SC. Okay, this A4 and A5 we need to use for SDA and SCL. For Mega, digital pin number 20 and 21. For Uno we are using analog pin, but for Mega we are using the digital pin. You can see this is the Mega board, and here clearly mentioned that Uno is not mentioned that, but in the case of Mega it's clearly mentioned that we are using SDA and SCL pin number 20 and 21. Okay. And for Leandro and Dio, other devices, the other Arduino board, digital pin number 2 and 3 for Leandro, and Dio pin number 20, 21, and separate two pins are there, SDA1 and SCL1. These are some examples of Arduino board that you need to identify which are the SD and SCL pin, and according to that you need to make the circuit diagram. Now for in this project, what exactly I am going to do, we are using DS1307 RTC model, as I said, is connected to Arduino with I2C bus to display the current date and time. That much only we are using this bus line, two devices, the two wire, we can say two wire communication, and we are retrieving the data from RTC and we send to the Arduino, and from Arduino with the help of serial monitor, serial communication, we are sending to the serial monitor. That is the task of our project. Now the component list, we required Arduino Uno and Mega, RTC DS1307 board, some hookup wire, and totalless breadboard. If you want to purchase these all the equipments, the link is available in description box. Now the circuit diagram is very simple, straightforward. If you check the RTC, that two parts, part 1 and P1 and P2 is there. We are using only P2. In P2, SCL we need to connect with the help of A5, and SDA we need to connect A4. Why? Because already I said Uno, A4 and A5. A4 is SDA and A5 is SCL. Because of that, SCL connected with A5 and SDA will connect with A4. VCC with 5 volt and ground with ground. Next part is coding. Now coding is little bit complicated, but I divided it according to various sections, like I went to the 6 sections, and I will explain the section one by one. If you understand that section, then it's well and good, by which if you combine all the code, then you are getting the combined code, how to retrieve the data from RTC to the Arduino on serial monitor. Then a part 1, what we are doing in each and every code, first we are defining the header files. Then here, as I said, we are using the two wire communication, a wire library. Because of that, we have mentioned that / include wire dot. After that, I defined some address. As I said, we are using several slaves with the help of master, and master identify, suppose I want to retrieve the data at particular slave, then in the case masters required the address, and our RTC module having the address in hexadecimal form, it is in this manner 0x68. Then in constant integer, that data type, variable name is DS1307, I mentioned that the same name. Under that I store that address. After that I made the two arrays, days and month. That two arrays, in that days I store the value Sunday, Monday, Tuesday, all 7 days, and in month all 12 months are stored. This is the first part in which I define the header file, address and data type. part 2 again I defined some more data type which I am retrieving from RTC. That is nothing but second, minute, hours, weekday, month, year. These are the data I need to retrieve, by which I can display the date, time and day and year properly. And the last the data type that I'm using to compare the data with the help of if condition, by which it can change the data is every minute. Because of that I'm storing some data, the current minute with the last minute, because I'm defining byte last minute is equal to 0. One more variable I'm using. This is for if condition I'm using. Now next part 3 we are using the setup, void setup and void loop function. In a void setup function, as we are using the two communication, wire communication and serial communication, because of that I'm starting the wire dot begin function, and after that serial dot begin to send first with from RTC data sent with the Arduino. For that purpose I'm using the wire communication, wire dot begin, and from Arduino to our system on monitor on display with the help of serial monitor. For that we are using the serial communication. For that purpose I define serial dot begin, and the data rate at which it is transferring the data is 9600. If you want to learn more about the serial communication, in that case you can watch my 10.1 part. This is all about the void setup. After that, void loop. First we'll read the time. These are again function. We will see the function, what kind of commands are there afterwards. Just simplification I'm defining here the function read time. First we'll read the time. In a if condition we'll check the whatever the read time is there, that minute it's not equal to last minute. If it's not equal to, then and only we'll print the time, and in the last minute the current minute will be stored, otherwise nothing will be happening. Now here we are using the two functions, read time and print time, that we'll see in detail afterward. In part 4, first we'll start the read time. What exactly we are doing the read time? In the read time with the help of wire communication, we are retrieving the time from RTC model to Arduino. The read time. What we are doing? We are retrieving the date, time from day from the RTC to the Arduino. For that purpose, first we'll begin the communication wire dot begin transmission, and we are passing the address exactly which place we want to retrieve the data. That slave is nothing but DS1307. Already address I store under this variable. This is a variable name DS13. Don't be confused why I'm writing the DS13. This is a variable I defined initially, and under that I store the address of that device. That you need to check the data sheet of particular device which is working on I2C protocol, and that address you need to store. With the help of that address, Arduino will easily identify, a microcontroller will easily identify from which slaves we need to communicate. Then here we are communicating with RTC, only single device is there. We are sending some data byte 0. And after that, if it is communicated properly, then wire dot end transmission. That transmission is completed. After that, we will define wire dot request form. We want to retrieve the 7 bits in the package that I am defining here. DS1301. From this address, we need to retrieve the data at 7-bit package. After that, we will retrieve second, minute, hours, week, day, month, and year with the help of this simple function BCT to day. That is a binary coded decimal to decimal. This is function that we'll see afterward. Again, it is a function. At the end, we will discuss clearly. The simple function, just keep in mind, binary coded decimal, we are converted to decimal. And here, whatever the data we will get, that data we are getting binary coded decimal, and that we need to convert into decimal. And here, wire dot read first, it will be the second. After it, read the minute, hours, weekday, month, and year. Month, day, month, and year. And serially, that data we are storing in this variable second, minute, hour, weekday, month, and year. Then here we retrieve the data. That data is in the Arduino. Now next we want to print the data. Now we need to send the data from Arduino to our serial monitor, we can say. For that purpose, what we are doing, I defined one array, we can say buffer array, character array with the that size of 3. Again, I defined the AMPN some variable by which I can store inside the AMPN. Right now I need to display the AM or PM exactly from that R, because in Arduino having that AM PM is not, we are getting from RTC. From RTC we are only getting the R's in 24, like 0 to 23. Then from that we need to identify if it is greater than 12, that definitely it will be PM. If it is less than 12, it is AM, and that according to that we will store in AM PM variable where AM or PM. Now we are starting the printing. The serial.print days bracket weekdays -1 bracket close. Now might be confused why I am using -1 over here. Already I got the weekdays, the data is stored, I really can print it. But don't forget, in the constant character day initial code part 1 of this 6, first part of this code, there I defined the data type day, and under that I store the 7 days: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. If you know the remember regarding the array, whatever I explained in the part of that array video, If you don't know, then you can check it on my channel. The video is available. Otherwise, just see, watch it, what exactly array is there, and you will get it. In the array, the numbering starting from 0, 0, 1, 2, 3, 4, 5, 6. But in the case of RTC, the numbering starting from 1, 2, 3, 4, 5, 6. For RTC, Wednesday is 4. But for our array, Wednesday is 3. Address is 3. For that purpose, weekdays minus 1. Suppose RTC send is 4, but I require 3. Because of 4 minus 1, I will get the 3. If RTC says Friday, then Friday according to RTC it will be 6. But for the array it is a 5. Because of that, 6 minus 1, we will get the exact 5. To get the exact date and time, because of that I am using that weekdays minus 1. And similarly, after that we will print some space, and after that we will print the month. And again month also we are using the array, and the same thing we are getting month minus 1. Again we will see print some space, month a day, it is a some integer value we can say, then no need to do minus 1 and all those things. Whatever data we got, we will print it. 20 year space. Now we need to check whether it is AM and PM. For that purpose, what exactly we are doing, we'll check the up. Whether if hours is greater than 12, then here with the help of compound operator, what we are doing, we are converting that hours into 12-hour format. For example, suppose R is 14. As hours is greater than 12, it will be approved. Then here what exactly we are doing, R minus equal to 12 means hours is equal to hours minus 12. If hours is 14, 14 minus 12, the time will be, we are getting the 2. Hours will be changed, instead of 14 hours now is 2, and AM PM will be PM because it is going beyond 12. If beyond 12 it is going, that means it is a PM. Else it maintain AM, and whatever the hours is that are same will be given. And after that, only after converting that R24 in terms of 12 AM PM, it will serial dot print hours colon. Now that buffer I define, why I am defining the buffer, that buffer I am defining, suppose time is 3:45, then no use of buffer, I am getting the exactly. But suppose time is 3:06, 3 hours and 6 minutes. In that case, if I am not using the buffer, I will get like this printing, which is little bit odd because we require 3:06. Then buffer, what exactly, this is a C code, we can say C type code, in which we are using sprintf buffer comma inverted comma percentage 02d minute, by which we are adding the 0 before 6, and after that buffer value I am printing. Okay, minute value I am sending help of buffer, and the buffer I am sending the minute 6, and with the help of buffer I am getting 06, and that serial I am printing. And at the end, normal serial dot print AM here, like this we are doing. Then here we will done regarding the read time and print time. If suppose you are a little bit confused, then you need to rewind it and watch it one more again. Now last part, we need to check BCD to DCD. Might be you remember in the read time we use this function BCD to D. That is a binary coded decimal to decimal, that function. Under that I am sending that value from that function, whatever the value I read it, that value I am sending. And here some simple mathematics is that mathematics is val, whatever the value I send, val divided by 10 multiplied by 16 plus val percentage 10, that is a reminder we can say 10. Then might be it is a little bit confused what exactly I'm doing though, why this equation is there. That equation is very simple. For example, you can just check it over here. I just copied from the some Arduino forum, that from where someone is explaining. I also not getting exactly how that formula came and what exactly. Because of that I go on that site and I try to understand what exactly the formula is this. Suppose I want to print the date 25. But already we know that Arduino and computer is dealing with the decimal values, sorry, binary value. Then that 25, if I want to convert binary coded decimal to decimal, in that case what I will do, the 25 divided by 10, as it is an integer, I will get 2. I will not get 2.5, I will get 2. Multiply by 16, it will be 32. Then here in this bracket, 25 divided by 10, 2, multiply by 16, 32. This bracket is 32. After this bracket, value is 25 percentage 10, that is a reminder we will get, and reminder I will get 5. Now here is 5, here is 32. If I add 32 plus 5, I will get 37. If you remember that 25 separately 2 and 5, the number is 0010 for 2 and 010 for the 5, and 37 also having the same binary number. 37 combined, it is same, but separate 2 and 5, this is that is the meaning of binary coded to decimal. That means again I am converting decimal only. I'm getting 37. I'm not getting the binary number, but that binary number, if afterward if I convert, then I'm getting the same 25 number in combined. It is a separate 2 and 5. and combine and give the same thing. That is all about the binary coded to decimal, and that data it is readable for the wire communication with the help of that system, that code. This is all about the code. I hope you got it, whatever I explained. You can just see if I enter, and this is a 2 and 5 in decimal format. That's in 2001, 0010 and 50101. The same thing we're getting, and if you're 37, if you check, the same number you will get. Now this is all about the theory part. Now let's see the demonstration, how it works on actual demonstration on video. What kind of output we'll get, we'll see it. Okay, now let's take the circuit, how it's played. Now already I explained regarding the RTC. Total RTC 4 pins are there. The first pin on right hand side we can say it is a ground. After that positive VCC, then SDL, and last one is SCL. Then whatever I explained in the circuit diagram in our PPT, the same manner I connected. That ground pin I connected with the help of yellow wire to the ground. The positive VCC with the help of red wire connected to positive VCC. You can check the SDL pin with the help of black wire I connected with SDL pin in Arduino Mega. The separate pin is there, pin number 20, and SCL pin I connected with pin number 22. Again the separate pin is the digital pin number 22. Then I connected the SCL pin. This manner I connected all, I made all the connection. Now let's connect our circuit with our system. Okay, now just connected. Now let's see in our screen. Already whatever the code I explained in our presentation, the same code I typed over here. Wire 1, the name is wire 1 I just given because I am using the wire library. Because of that I have given the name wire 1. Let's maximize it. Already explained this all the codes. Let's first verify the code. Take some couple of seconds. Compiling the sketch, and compiling is done, no error we have got. Now let's upload the code. Now just see, when we are uploading the code, then TR and RX, the LED is blinking like anything, like whatever I explained the last time, the same manner. Now already the code is uploaded. Now to retrieve the date and time, we need to open the serial monitor. Let's open the serial monitor is open, and you can check here the time, as the time is mentioned, Friday 1st June 4:28 PM. The same manner time is display 2018. Friday June 1 2018 4:28, and every 1 second, after every 1 second we can see still it is 20 seconds, half of second is left, after half of minute is left. After every minute the time will be refreshed, and that time the Arduino will retrieve the time after every minute, and that time will be displayed on our screen. That time we are not taking from the system. This time I'm getting from the RTC module, which is I connected with the Arduino board, and the serial communication I'm displaying the time on this serial monitor. Only some few seconds are left, and after few seconds you can check when the time is changed over here. Here is 4:28, when here it is became 4:29. The time this time is changed 4:29, and you can check here time is 4:29. As the time changes, the time will be displayed over there. Now this is a simple way with the help of wire library how to retrieve the data with the help of that SDL and SCL communication I2C protocol that I explained over here. Now let's continue with our presentation. Okay, I hope you got it, how to retrieve the data with the help of RTC through wire communication serial monitor. Now if you want to learn more regarding that wire library or RTC, yes, real-time clock, in that case you can refer the beginning.arduino events technology in action, or you can refer www.arduino.cc forum site, where also some resource material is available. Okay, thank you very much for watching my all entire series of introduction of Arduino programming, introduction of basics of Arduino programming. You can see my previous video, introduction to mechatronics, electrical actuation system, and introduction to pneumatic system. The link is available in description box in this card icon, and you can visit my channel www.youtube.com/mrkhanacademy. And one more thing, after that this series I'm going to start the new series related with hydraulic. If you want to require the update of hydraulic, in that case please hit the like button on this video, share this video with your friends also, and do not forget to hit the subscribe my channel to motivate me to make a such video in future also, and you will get notification also. Thank you very much. Bye bye, take care, see you soon.